So my name is Naveen Chand. I'm a product manager. I work on Google Cloud and identity on GCP. Today I'll be presenting with some of my esteemed colleagues, Blake and Breno, who you'll get to meet in a few minutes. So why are we here? GCP offers a myriad of different identity capabilities, but what are the best identity features to use in specific scenarios? Today, in this talk, we'll walk through an overview of many of the different capabilities. We won't be going super deep into them, but we'll give you a good end-to-end picture of what that would look like and how you can stitch a solution together. We'll also link you to many of the other talks that will be taking place that will deep dive into many of the technologies that we covered today. In order to walk through the scenarios today, we're going to be introducing a company named Zotkix, which is a fictitious company that is a multinational organization. They have a distributed sales team where they have salespeople that are coming from many different locations. They have a customer-facing portal, and one of their top objectives for 2019 is really this notion of digital transformation. So today, some of the goals for Zotkix is really to get their users onboarded onto GCP, make sure they're able to protect their sensitive accounts, securely and scalably manage access to GCP, be able to seamlessly enable their distributed sales force to get access to GCP in a quick and efficient manner, making sure that they can administer authentication and authorization consistently across their environments. And really, they have a customer-facing portal as well that they wish to reduce the complexity on the identity aspect. So digging in a little bit into their architecture, they have a few different types of identity that Zotkix handles. There's employees, partners, and services, which are all represented in their Active Directory instance in this case. They also have a homegrown CIAM, or Customer Identity and Access Management solution, which powers their portal page, and that's where their end-user identities are actually stored. So the first thing we're going to walk through is really, how does Zotkix go and grant access into GCP? So we'll be highlighting a few of the identity types, so administrators granting access, developers, and also groups that encompass both of these different identity types. So after Zotkix is registered with GCP and created an organization, they need to give their admins and developers access to the platform. In order to grant access to their developers, they use Google Cloud Identity, which is a Google service that allows customers to create, manage users and groups, and how they'll have access to cloud resources. In addition to granting access to GCP, Google Cloud Identity is a complete IDaaS offering that is also available as a standalone product, supports robust lifecycle management, device policies, and provisioning across a multitude of applications. So as Zotkix masters all their identities on-prem, the first step is really to get those identities inside of Cloud Identity, and they can leverage one of GCP tools called Google Cloud Directory Sync, or GCDS for short. This tool allows you to go and select which users in your AD instance by doing either an LDAP filter, selecting specific OUs, but saying these are the set of folks that I believe need to get access to my GCP resources, and so they can synchronize those identities over. The next step is actually granting single sign-on for these people. So in addition to having representation, they want them to be able to use the username and password that they use with their AD instances in order to get in. So in order to achieve this, Zotkix could go and configure a federation broker and use protocols like SAML in order to go get single sign-on working with GCP. If Zotkix happened to use one of these other identity platforms, they could have used some of the capabilities that are built into them that allow these platforms to directly provision into Google Cloud Identity. So we talked about employees, we talked about customers, talked a little bit more about service accounts for a second. Now, service accounts are really an identity for your application that enable programmatic off-fabric access in many scenarios as well. We're going to walk through one specific example in which you have an application that's running on-premise that needs to get access into GCP, in this case, a GCS bucket. So in order to do this, because you have an application, you don't want to have a username and password stored somewhere locally in your on-prem environment. So that's why you would create a service account. And with that service account, you could take a service account key or create a key on it, use that from the on-prem environment in order to be able to authenticate up to Google Cloud. Now, some of the best practices with service accounts, because these service accounts or robot accounts are usually fairly powerful, as always, the principle of least privilege is extremely important. Also, controlling your service accounts through policy. We'll be talking about a few of the different policy types that are possible and allow you to go and have much more granular control over where service accounts are used and how they're used. Using features like descriptions that allow you to go and specify this is the intent that why this service account was actually created. And then the last, one of the most important parts, is really to protect those downloaded keys. So developer keys should not have access to prod resources, for example. Making sure that those keys are actually rotated and having a recurring cadence through which you actually do rotation. And then auditing the service account keys that have also been created in your environment. So we've talked about how Zotcakes was able to go and grant their users access into GCP. They're now able to single sign on. The next step is really to take some of those sensitive accounts and make sure that we have an extra layer of protection on top of them. And for this, one of the best practices that we recommend, especially for the highly privileged accounts, is using security keys. So based on FIDO standards, security keys are phishing-resistant second factors that use cryptographic challenge and responses to provide to provide integrity of the authentication session. So keep your eyes peeled. There'll be an announcement coming on 410 on something new in this area. So just looking at the next level inside of security keys and just to learn a little bit more about how they work. The core idea is, in this case, Alice is navigating to a website, and when she tries to sign in, the server gives a challenge to the login web page. The web page asks the browser for a security key signature, and then you'll notice that it passes that to the security key that actually goes and encrypts the entire package, both the URL that Alice is actually looking at right now, along with the challenge that was sent from the server. That is sent back up all the way to the server, which is now able to see that Alice's key signed this. This was the actual current challenge that was actually specified. And most critically, Alice was actually pointing to google.com, not some other website. And this is where that protection around phishing attacks actually comes in. If somebody was to send Alice an email with a link that said goggle.com, for example, she would actually be able to go and the server would actually reject the call, realizing that she's not on the website that she was actually intended to be on. So with that, I'm going to hand it over to my colleague, Blake, who's going to walk us through an access management.
Great. Hi, everyone. My name is Blake. I'm a product manager on Google Cloud IAM, and I'd like to thank Naveen for kicking us off with an overview of identity. Before we get into best practices, however, I do want to have a quick refresher course in some of the core concepts that are related here. And let's start with the resource hierarchy. The entire idea behind the resource hierarchy is so that you can easily map your organizational structure to GCP for easy discoverability of resources, for delegation, and for access policy management. And there are three key types of objects that exist in your hierarchy. The first, at the very top, is your organization. This is automatically provisioned when you sign up for Google Cloud, and everything, every GCP service, every project, every folder will exist underneath this object. And so, next, let's talk about folders. Folders are really used for splitting up your GCP resources in a manner that matches your internal structure and is conducive to administration and policy management. There are definitely some best practices here that we'll get into momentarily. But at least within GCP right now, you are allowed up to 4 levels of folders for organizing your resources. And finally, you have projects. By number, at least besides the services themselves, these are probably the most numerous resource type you're going to have in your hierarchy. And ultimately, your workloads and GCP services are going to reside inside of a project. Now, some GCP services do allow for more granular management of access policy below the project level, but most don't. And so this is going to be a frequent attachment point for your access policies in GCP. So let's talk about Cloud IAM itself. Cloud IAM is really all about who can do what on which resources. Now, we've already talked about the who. Naveen took us through users, groups, and service accounts. So let's really start with the what. The what is what a principal can do, and that is done through the granting of permissions. Now, in GCP, you cannot actually directly grant permissions to a principal. This is done through the use of a role, roles being groups of permissions. And lastly, the on what resource part. So in GCP, you apply policies to the resources themselves. And so the typical attachment points in your resource hierarchy are going to be that organization, your folders, or your projects. And it's important to note there's actually a pretty big benefit to attaching policies in this way, which is that the role, or in effect the permissions that the principal gets, can be different for different resources depending on where you attach those policies. Now, the notion of inheritance is also very important here, because based on where you apply a policy in this hierarchy, the access that you've granted is going to inherit down to everything below that level. Let's take a quick look at an example. So here, let's say you gave a bucket admin role to a user at the organization level. That user is now able to access any bucket inside of that organization. Similarly, though, let's say that you granted that role to a user on that first folder. In this case, they're able to access all the storage buckets only underneath those first two projects, because those projects are underneath that folder. And finally, applying that policy to an individual project would only grant the user to the 3 buckets, for example, in this first project. So to round out our refresher, let's take a view of what a policy actually looks like. Now, keep in mind that since policies are attached to resources, it's the applicable resource is really implied through that attachment. So what's in the policy is primarily 2 things. 1, the role, which again, a collection of permissions, and 2, the members, who you are granting those permissions to. Now, there are 2 key focuses here as we get into best practices to make life easier for a company like Zotkix, a large company like Zotkix. The first is that we want to make administration manageable, to make policy administration manageable. Zotkix also wants to make sure they're doing everything that they can to achieve that principle of least privilege. So for the first, one of the best things that Zotkix can do is make sure that they start off using their resource hierarchy correctly. Since we know that Zotkix is a large company with multiple business units that do operate for the most part independently, we can make that our first layer of folders. We've got your 3 business units up there. Underneath that, let's say potentially 1 folder per team. Below that, a folder for an app. Below that, a folder for an environment. The benefit to arranging things in this manner is that Zotkix can significantly reduce the number of policies they need to manage, while also maintaining the desired isolation they want between their business units, their teams, their applications, and their environments. So in this, to look at a few use cases here, so cloud administrators for each of their business units can be granted the necessary access at each of these top levels and have that inherit down to everything in their business unit. SRE on-call groups could be configured at the team or app-level folders for what they're supporting. Engineering teams could be given their foundational access at the team level with only the more granular policies applied down below. So by making use of the resource hierarchy, Zotkix was able to avoid having to specify all of these policies in a very duplicative way separately on all of their projects. Now, moving on to achieving least privilege, Zotkix has a few options available to them. While they started out using the primitive roles that we offer in GCP, owner, editor, and viewer, they quickly found these to be far too permissive when it actually comes to achieving that principle of least privilege. And as a result, they started using curated roles for their access grants. These have narrower access, they're generally focused by service, and even further by persona or job role. So there are several hundred of these roles in GCP that Google creates, that they curate, and you can see some examples of those here. But for some of their grants, Zotkix found that even the curated roles that we were providing were close, but not exactly what they were looking for when it comes to granting access. And so as a result, they decided to take a look at custom roles. Here, for example, they copied one of the BigQuery curated roles and removed a couple of permissions they didn't want to grant. In other cases, Zotkix can do the same, but add a few additional permissions. They could also combine two curated roles to simplify their access grants. Finally today, let's take a look at a feature that will be entering public beta soon that will allow Zotkix to configure their access controls in even more of a finer-grained manner. IAM Conditions adds a layer of attribute-based access control on top of the role-based access control concepts that we just went through. Essentially, this allows you to configure role grants that provide access to a principal only if certain other conditions are also met. One such example of a condition would be granting access based on time. There's a couple different ways you can do this. One would be configuring an access grant that is only valid before a specified expiration time. This can be helpful for break glass scenarios, such as giving a developer 2 hours of access to production to fix an issue, knowing that that access grant will be automatically revoked. This could also be done as part of a recurring schedule, granting access to a resource, let's say Monday through Friday, 9 to 5. Another use could be during project-level grants that only allow access to some of the resources of a given type in that project. For example, you could grant a compute admin role to a user, but with conditions, specify that that user can only manage VMs whose name starts with test dash or whatever other prefix you wanted to use. And finally, you can use conditions for context-aware access as well by configuring a grant that is valid only so long as aspects of that user's context, such as their IP address or device security policy, are met. Great. So now that Zotkix has optimally configured their access policies for their GCP resources, they're now ready to move on to extending that access so that their distributed sales teams can access internally built corporate apps that they need. Brenna will tell you more about that.
Okay, so as Blake mentioned, I'll now cover how Zotkix can enable seamless access to their apps and services for usage by their distributed sales force, for instance, and also how they can securely support their employees and developers to work from home without need of a VPN. So let's now recap where Zotkix stands on their modernization effort. Zotkix migrated some corp apps and their consumer portal to the cloud, but they still run several apps on premises. They want to enable the employees to access both sets of apps from their workplaces, from their homes, and on the road. And they need that their sales and their partner staff be able to access tools and demos when visiting a customer's location, maybe when they're attending Cloud Next, or anywhere. So here we introduce the BeyondCorp security model. So starting in 2011, Google created a new approach for access management, the BeyondCorp Enterprise Security Model. It's a zero-trust security model. That means that requests are not granted just based on where they originate in the network. Instead, BeyondCorp insists on verifying that the requester has permissions to access the services that they invoke. So BeyondCorp shifts access controls from the network perimeter to individuals, users, and devices, and allow employees to work securely from any location. So let's look a little closer on how BeyondCorp works and how it can help Zotkix. So first, let's look at the BeyondCorp solution components, okay? It requires that, for instance, you have a strong notion of user identity. It doesn't insist that you use phishing-resistant authentication, but it can leverage that information, the information about the session strength, to make decisions based on the sensitivity of the request. It also requires context information, such as location, device status, etc. It requires a rules engine that allows the IT security teams to define access rules. And finally, it defines enforcement points that control access to the various resource types, such as web apps, VMs, APIs, etc. So Google Cloud provides a solution to enable the BeyondCorp security model for your apps and infrastructure. This solution is called context-aware access. It integrates with multiple Google Cloud services to make BeyondCorp possible for your organization. So one of the components is called VPC Service Controls, VPCSC for short, and it improves your ability to mitigate the risk of data exfiltration from Google managed services, like Cloud Store and BigQuery. With VPC Service Controls, you can configure context-aware security perimeters around the resources on your Google managed services. And you also can control the movement of data across the perimeter, egress controls. Cloud IAM we covered, thanks to Blake's presentation earlier. And for Cloud IAP, as the identity-aware proxy, it provides the enforcement point for the ingress rules. So it's an ingress proxy that provides level 4 to 7 network filtering capabilities. Now we are going to see how Zoctix can achieve consistent security and access control management across their various environments between on-premise and cloud-based apps. So for that, I'll introduce Istio, if you haven't heard about it. Istio is an open source service mesh that layers transparently onto existing distributed applications. It is also a platform, including APIs that let it integrate into any logging platform, telemetry, or policy system. Istio's diverse feature set lets you efficiently run a distributed microservices architecture, and it provides a uniform way to secure, connect, and monitor microservices. So why would you use Istio? Istio makes it easy to create a network of deployed services with load balancing, service-to-service authentication, monitoring, and more, with few or no changes in service code. It can also be used to deliver secure service-to-service communication in a cluster with a strong identity-based authentication and authorization based on mutual TLS. And with Google as a major contributor to Istio development architecture, it means that using Istio, you can take advantage of best-in-class strategies for microservice mesh management. So you add Istio to services by deploying a sidecar proxy throughout your environment. It intercepts all network communication between microservices. One then configures and manages Istio using its control plane functionality. This allows, for instance, Zoctix to distribute policy about network accessibility, about authentication, authorization, and audit policies, as well as telemetry configuration. The configuration is consumed by the Envoy proxies attached to each workload instance, and policy is enforced by the infrastructure. So in particular, why use Istio security? So Istio delivers authentication, authorization, and audit as part of the platform, ensuring consistent compliance and removing the burden on app developers. In addition, authorization can use both the identities of the requesting user and of the connecting peer. Istio delivers automatic metrics, logs, and traces for all traffic within the cluster, including cluster ingress and egress. And it improves visibility into all operations and consistent audit support. So now let's look how Zoctix can leverage Istio and Google Managed Services to obtain consistent security across a hybrid deployment. First, let's look on how Zoctix addresses access management for the on-premises apps. In the examples, I will show Istio deployed in Kubernetes. In particular, in this scenario, Zoctix has deployed a GKE on-prem cluster. But I would like to emphasize that Istio does not require Kubernetes. It can be used to manage more traditional on-premise data centers. The Envoy proxy is deployed in ingress, as well as a sidecar in each pod. And it manages all connections in and out of the cluster and in and out of each pod. So that provides the Istio enforcement point. Now let's see how a corp user, which is authenticated with the corp credentials, can access services in the cluster. So here, when the corp user makes a request to the Zoctix HR app, Envoy terminates the TLS connection and enforces that the request includes user credentials. And it can perform any other ingress checks. Next, the request is going to, of course, be forwarded to the HR app. And the sidecar Envoy evaluates authorization rules. So for instance, it can require that the authenticating user have an administrative role if a privileged operation is invoked. As the request travels down the service stack, the HR app calls the backend, which also applies authorization rules. And these rules, as before I mentioned, they can be both on the peer, in this case is the front end for the HR app, as well as the requesting user. So now let's look at a situation where a corp user is accessing Zoctix on-premise cluster from overseas. So to take advantage of Google's fast and globe-spanning network, Zotkicks can route their remote access to their on-premise clusters through the identity-aware proxy in Google Cloud. IAP provides additional authorization features. For instance, it can ensure that access comes from a managed device. So this shows how BeyondCorp solutions can seamlessly extend to protect Zotkicks on-premise apps. In fact, many IAP customers choose to use IAP as their ingress proxy for all their apps, whether they are apps on GCP, on-premises, or in other clouds. Let's now look at how Zotkicks can protect its cloud apps. So we are assuming here that Zotkicks has already extended its identity and authentication system to GCP by syncing their Active Directory with Cloud Identity, as Naveen went over earlier. So in this case, Zotkicks has deployed a legacy application in a clouded hosted VM. IAP can be used to provide ingress enforcement of authentication and authorization when a Zotkicks employee accesses a legacy database hosted in GCP. Legacy applications can also be protected on premises and when located in other clouds. You can do this using an Istio ingress proxy or using IAP. And of course, if you use IAP, you get advantage of the benefit of the context-aware enforcement rules. So now we show how you can deploy Istio in GKE using IAP for ingress proxy in this scenario. Zotkicks can configure role-based access control in both IAP and in the Envoy sidecars on each pods. And for instance, again, IAP can deliver the context-aware functionality here, requiring, for instance, 2-second factor authentication or use of a trustworthy device. And the Envoy sidecar proxy can provide fine-grained authorization using service-specific configuration. We can also use the same architecture to protect access by end users of the customer portal. Authentication, authorization, and audit are throughout the service stack at every level. And this reduces trust between systems, which means that it mitigates user risk and it facilitates compliance activities. We also look here about how Istio can enhance security of service-to-service communications. In particular, Istio allows Zotkicks to deploy TLS certificates in each of their workloads. So services can now communicate to each other using mutual TLS to strongly identify their peer identity. Now let's explore how we can leverage the native workload identity of Kubernetes. And this can improve additional aspects of service-to-service authentication. For instance, it can provide simpler and more secure means to manage service credentials. Zotkicks can now add IAM bindings that allow a native Kubernetes workload identity to exercise an act as permission on a GCP service account. So Zotkicks can create a GCP service account and use that to grant access to specific permissions and resources, and then allow their workload identities the ability to impersonate these GCP service accounts. So by doing this, Zotkicks achieves security without burden of key management, because the authentication of native workload identities is handled by the Kubernetes infrastructure. So with workload identity, GCP services can more easily be consumed by Kubernetes workloads. In addition, it makes it even easier to leverage Google managed services such as Stackdriver monitoring and logging to seamlessly deliver functionality in the Istio platform. So tying it all together, we can see that in a hybrid deployment, Zotkicks can leverage open source Istio architecture and Google managed services such as IAP and Stackdriver in a well-integrated environment that delivers consistent, transparent, and auditable policy enforcement. In addition, through the integration of workload identity with IAM, Zotkicks can seamlessly consume GCP services from their GKE apps with improved security by eliminating the need to manage keys. So now I want to ask Naveen to continue this presentation by showing how Zotkicks can achieve their goal to simplify identity management in their consumer apps.
Thank you, Brenno. So hopefully that gave you a good overview of Istio, and we're going to continue on our story and our journey now, talking a little bit about customer identity and access management. So through the presentation so far, we've talked about identities for employees, we've talked about developers, group usage. We also talked about how kind of services would be protected and how you can use these across hybrid environments. And now we're heading into the customer identity and access management portion. So one of the challenges that Zotkicks has was, with its current solution, many of its people are stored in local CIAM instances that are stored and housed in several different parts of the country. But when these people went on travel, if a customer was accessing it from a different location than they were actually in, they experienced a lot of high latencies. So I'd like to introduce you to Google Cloud Identity Platform, which allows you to add customer and identity access management capabilities into your apps. So the identity platform takes the foundation of Google's extensive and mature identity infrastructure and provides them to developers in order to allow you to add this type of functionality into your apps, protect user accounts, and scale with the confidence that we've built throughout the Google stack. The platform includes a variety of capabilities that allows developers to select the type of functionality that they want. If they need a user store, it provides a user store. If you need to go and federate with identity systems that exist inside the industry, such as SAML or OIDC, it has that capability. And lastly, it also supports a multitude of different social auth providers. Now, one of the great things for Zotkicks is, because it's at Google and Google scale, whenever a person connects in, regardless of where they're connecting to, they actually get access onto the Google-connected instance of this closest to them. And so they would be able to get much reduced latencies for that initial authorization request on the Zotkicks infrastructure. One other thing to note about the identity platform is it was formerly called Cloud Identity for Customers and Partners. It has now been renamed to Identity Platform and is currently in GA as of today, so we encourage you to go and try that out. So just to wrap up, we talked about the different things that Zotkicks achieved. They were able to onboard their users to GCP, protect their sensitive accounts, securely manage kind of policies using many of the techniques that we talked about from the IAM portion, enable seamless access to their distributed sales team through tools like Identity Aware Proxy and the BeyondCorp model, administer authn and authz consistently across their environments using tools like Istio, and then finally simplify the complexity of their customer portal using the identity platform.